Hi, Bud Stein with ESI. Today we're going to talk just briefly about this word BIM that you hear being discussed on radio, on TV, possibly in any sector that has to do with building construction. And we're going to just kind of paint a picture of what BIM is. But before we can do that, we actually are going to go back in history. In fact, thousands of years. We're going to talk about where drafting started, or technical drawing started, and how we got to BIM today. It's a pretty interesting journey. First, we go back 4,000 years BC, and archaeologists found a stone that had a carving in it, or chiseled into it, the designs of a fortress that was going to be built in that area. And so we went from chiseling in stone to the time of Leonardo da Vinci, for example, and his beautiful drawings of the flying machine, the modern man, various things like that. And so we've seen drafting, technical drawing, going on for thousands and thousands, over 6,000 years now. And the reason why technical drafting works is because while there are various different language groups going on at the same time, actually, drawings are a common language of communication, similar to the way numbers are. And so by using a technical drawing, whether it was chiseled in stone or hand-drawn like artwork from Leonardo da Vinci, they were able to communicate across many different societies with what their ultimate goals were. Coming up to modern time, for example, in the last 40 years, things have changed significantly. 40 years ago, we were using T-squares and triangles, and everybody was drawing using these basic tools with pencils and erasers. And the drawings were very much like artwork. In fact, every architect or engineer had his own style. His lettering style, his line work style was unique to him or her. And thus, that was their hallmark. That's what made them different. And you could look at a drawing from a certain person, like Frank Lloyd Wright, for example, and see his style in both the line work, the lettering, and in the building design itself. So this T-square and triangle type drawing went on for many years, and it stood out as the standard. And that's where we got the term, when we look at something that's a blueprint, because it was a blue background with white lines. And that was a process that they used at the time. Now, in order to make things faster, to produce work more effectively, these things called manual drafting machines came on the scene. A manual drafting machine is pretty much just a technical tool that's attached to a drawing board and allowed you to draw more quickly, more efficiently. So younger people were drawing that didn't have quite the high skill quality of artwork that the architects and engineers of the time had, but they were turning out work faster, and that was really important. In fact, there were things invented called Croy machines and lettering systems that could allow people to draw so that their lettering looked consistent. It took some of the artwork out, but they were able to produce drawings faster. In 1980, a gentleman named Fred Stitt wrote a book called Systems Drafting. Now, what happened was you would put a pin bar at the top of your drafting machine table, and then you would overlay various different disciplines. You'd have an architectural background with an electrical drawing on top and a mechanical drawing on top and details off to the side. And so we were becoming more efficient, more technical with our drafting systems, and that became then a big drive and a big push in the industry to become faster, to become better, to become more efficient, with the minor sacrifice of the artistic character and artistic nature of the drawings. Moving into the computer age, now we have big mainframe computers in the 1970s and 80s that were used to plot just a few lines and draw them out, but it was all the rage. Now, these computers were as big as your garage. And they could only be afforded by organizations like the Department of Defense or the auto industry or the shipbuilders, people and organizations like that. But with the advent of the PC, this is when we started to see a huge surge in electronic drafting. The term CAD came on the scene. In the 1980s, two different companies were fighting for market share. They were Autodesk and MicroStation. And those two companies fought tooth and nail to get their CAD packages out to these PCs and for people to start drawing using these electronic tools. These two companies were like the Hatfields and McCoys, though. They just couldn't communicate. If you did a drawing, a DGN file in MicroStation, and you wanted to convert it to a DWG file in AutoCAD, it was chaos. Very complicated, very difficult. So, though they went their various ways and they grabbed their various market share, today we know AutoCAD is pretty much the standard in drafting, whether you get it in high school or you know someone that uses it, and MicroStation is pretty much the standard used by the Department of Transportation for bridges, highways, and projects like that. So with these CAD packages, we were able to now standardize the look of every drawing. There was no longer that artistic rendering, but instead it was quick replication and changing and production of two-dimensional drawings. Really significantly increased the speed. Unfortunately, it made us make mistakes faster too. But either way, it was the way of the industry and it was moving forward. And so when we were implementing in the 80s with architects and engineers all over the country, we would implement AutoCAD and transition them to from hand drafting to AutoCAD, and invariably they would ask, okay, which button do I push now to turn this into an elevation or a section or a 3D perspective? And of course, we had to disappoint them every time and say, there is no magic button. There's nothing there yet. It's many years away. Well, those times have come upon us now. So with that desire and that push of the market to produce 3D drawings, AutoCAD and MicroStation both started to put 3D capabilities within their software. Now these capabilities were not true BIM. There was no information. They were just line work that looked like 3D and could be rotated around. So if we did a perspective, instead of a hand perspective drafter doing a perspective, setting it for a 6-foot-tall person, but you want to see it from the viewpoint of a 20-foot tall perspective, you were sunk because that hand-drafted perspective was stuck. With 3D CAD, though, you could rotate the model around and you could take a look at it. And this was a big deal. So then you could shade it, you could render it. Naturally, it brought the computer to its knees, but now we were seeing progress. People were starting to see that you can communicate in 3D with these electronic CAD drafting tools. And so that's where CAD and electronic drafting was until recently. As of recent, this word BIM has come on the stage. And it's no longer just about high-speed production and changes. It's now about information. So BIM tools like Revit, which is an Autodesk product, are available for a person to build a building using the actual elements. When you put a W12 by 24 column or beam in, you are actually dealing with an entity that has all the characteristics and all the capabilities of that piece of steel. And so this became powerful. Now you were not only drawing lines, which were symbols, which is the universal way we communicated for centuries. We had a little image that represented a symbol. We would draft it by hand or by CAD, and it would go into the field, and the contractor would look at it and know exactly what that particular image represented. Well, now with BIM, you are producing the actual image of what is going to go in the field. In fact, when you talk about the symbol of a globe valve, which is a little butterfly-looking image, now there are globe valve companies who manufacture these little parts, and those parts are fully modeled and put into your drawing. So you are physically looking at an identical species of exactly what that globe valve is and all the characteristics that come with that. So BIM, building information modeling, it allows us to do 2D. Actually, you're always producing in 3D, but it can spit out 2D to AutoCAD, to hard copy plots and prints, PDFs, whatever you want. But it also has information, intelligence. the ability to analyze your building. And finally, modeling. Well, although it's a much larger term than just 3D, we'll just use that as an illustration. With modeling, we now get to see the building as it truly exists before it's built. We can work out all those coordination and clash issues in a building before we ever buy one piece of material. So massive savings. So BIM allows us to come up with the concept of a building, find out if it's buildable and functional, look at all the clash, get all the other disciplines involved in working with a real model, not in 2D but 3D, and then when the model is finished, you have a much more mature end product, thus reducing the change orders and the complications that come with trying to coordinate teams in a two-dimensional world. So from chiseling on a stone to modeling in 3D and analyzing that information, we have come that far in those 6,000 years.